So we have a minimum sum problem. So what it says that Manisha has two positive numbers. So there are two positive numbers and the product of them is 64. Yeah, there are two positive numbers. The product is 64. And asking what is the minimum sum? What's the minimum sum that she can obtain by these numbers? And explain why there cannot be a larger sum. Asking why there can be a larger sum. So let's try to answer the question. So let's do the first part. Question is asking what is the minimum sum that she can obtain by these numbers. So we can start the problem like this. So we're going to say let x and y be the two numbers. Let x and y be the two numbers. And then we know that the product is 64. So we can write, so then you can write, since the product is 64, we can write x times y equals 64. So that is the constraint. So we use a constraint and write it x times y equals 64. Now let's write the objective function. Objective function in this case is a sum equal the sum. So we know that the sum for this one is, so we can probably use s for that, just like a very meaningful letter. So sum, which is x plus y. So that is the one we try to minimize. So sum x plus 1, and you notice that there are two variables here. So there are two variables, and then we know that with two variables actually you cannot find the maximum minimum in calculus 1. It's a calculus 2 topic. So what we can do, we're going to remove this one variable. So let's try to remove y. To do that, what we can do, we're going to go back and then try to solve for y. And if you divide both sides by x, you can write this one as 64 over x. And then we also know that there are no division by 0 situations, because we know that the x has x and y both are positive. So there are no division by 0 situations here. Okay, now what we can do, we can substitute that here. So it is x plus y equals 64 divided by x. So that is the function you get, and then also on x greater than 0, because that's the condition. So that's the one, and then you can see is x greater than 0. So and then you see that there are no endpoints in this case. There are no minimum value. So there are no endpoints. That means we cannot use the absolute extrema test for this problem. And also, what the shape of the graph? This is like a very interesting graph. And if you look at the graph, this is what happened. So you can see that when x is small, because 64 divided by x, because 1 of x, this gets large. So when x is small, large. When x is large, this fraction go to small, but there's an x term here. So it's again large. So when x is small, it's large. When x is large, it's also large. So that means the graph gonna be, when x is small, it's large, it's gonna go like that, asymptote, and then gonna turn and go back. So that's the kind of graph you're gonna get for this problem. So it's very interesting. These kind of things will happen in like physics and stuff like that. So what you're trying to do is you try to find what is this minimum value. That's what we are looking for. So you see that it's not obvious for this problem. It's not obvious. So what we're going to do, we're going to use the calculus for that. So the idea is we try to use the derivative. We're going to look for the critical point. So let's do that. So for the critical points, what we're going to do, we can take the derivative of this function. So we're looking for s prime x, the derivative. And you can see it's very easy to take the derivative of the first term. What's the derivative of the second term? So second term look like 64x. So we can write this one as 64x to the negative 1. Then when you take the derivative, it is negative. You can see you're going to subtract 1. So it is 64 x to the negative 2. We subtract 1. So that's the derivative you get. So that means, and then if you write this in the denominators, you can write like beta like this. So negative 64 divided by x squared. So that's what you get. So that's the derivative. Now what we're going to do is we're going to simplify this and try to set this one equal to 0. So we can try to set this one equal to 0 and then try to solve for x, for critical points. So let's do that now. So we have s prime x, which is 1 minus 64 divided by x squared. If you multiply the top and bottom by x squared of the first term, you can write this one as x squared minus 64 divided by x squared. We can set this one equal to 0. And you can see that there are discontinuity is coming from the denominator, but you know that it cannot be 0, so those are the ones. So it is x equals 0. We normally x not equal 0, so that's the critical points coming from the denominator, but those points are not in the domain, so we don't want to worry about that. So only thing that comes from this one is the top one. So what we do, we're going to set the top equal to 0. So it is 64 minus x squared equal to 0. So this is that x squared equal to 64. In other words, x is equal to plus or minus 8. But you know that x has to be positive. So that means x equal negative 8. So it cannot be equal to negative 8 because x has to be positive. So the only solution that you're going to get from this one is x equal 8. So that means the only critical point that's in the domain is x equal 8. So it's a one critical point situation again. So now what we do after we get the critical point, we want to make sure that there is a minimum at this point. So for that, so it's a test. So we're going to check this. So what do you do for that? We're going to do the second derivative test. So let's look at the second derivative of this one. So if you take the second derivative, how we do that? We're going to same trick, because you get a negative 64 x to the negative 2. So the second derivative would be, you're going to multiply the negative with the negative 2, so you get 2. So you get 128 x to the negative 3 as the derivative. So that means you can write this one as 128 over x cube as a derivative. And then you can see that at x equal 8, what's going to happen is x second derivative, which is x8, equal 128 over 8 cube, and you only need to know it is positive. You don't even want to simplify this one. It's positive. Positive means by the second derivative test, you know that this is positive, means has a minimum. So that means as at the critical point, x equal 8, there is a minimum. Now what we know, since we know that there's a minimum, we're going to find the minimum. How to do that? We're going to find the corresponding y value now. So we normally do this first. So we're going to find the corresponding y value. So you can say when x equal 8, y equal 64 divided by x, which is 64 divided by 8, which is 8. So y equal 8. So the minimum product, minimum sum. So we can write this directly now. Minimum sum is 8 plus 8, 16. So 16 is the minimum sum that she can get from those two numbers. So that means if you go back to the graph, so what happened is, so we see that the graph going like that. Actually, there's asymptote here. So the minimum value happened at x equal 8. The minimum is 16. So that's what happened. Okay, so that's how we answer the first part of the question. So let's answer the second part of the question now. The second part is asking why there is no larger sum. So let's try to kind of see it. You can see that the product has to be 64. So for example, you can pick numbers like 1 over 10 times 640. When you do that, and you can see you get 64. And also you can say 1 over 100 times 6400. So this is going to be 64 again. So you can keep doing it. So the idea is you're going to put the same number of zeros in these two places. So that means if you do write it mathematically, and then you can see that when you add them, you get like a large number. So that's the idea. So that means, so we can see for n, integer n, like n is integer, we can, so we're going to pick the two numbers. One is 1 over n, and the other one is 64 times n. And then you can see that then the product, 1 over n times 64 n equals 64 because they cancel out, and then the sum equal 1 over n plus 64n, and you can see this is bigger than 64n because you are adding something. small. So that means it can be really large. So this is large for large n. So you can see this is large for large n. So that means because of that, so there's no a maximum value for this one. Okay, so there's no. So because of that, so thus no a largest sum. Okay, it can be any big number. Okay, that's how you kind of prove the second part.